now going to try integrating some slightly more complicated functions. I want you to keep in mind at all times, though, that integration is the anti-differentiation. It's the opposite. So if you're ever lost or you're not sure what to do, have a look at what you've got in your answer and say, if I differentiated that, would I get back to what's inside that integral? And if not, what do I need to do? Okay, so what I mean is, have a look at this first one. We've got 3x plus 1 all to the power of 5. And I want to know what happens when I integrate that. What's the primitive of that? Well, I know that I'm supposed to add 1 to the power. So I have 3x plus 1. I add 1 to the power. But I know that when I differentiate that, I should end up with a 6 in front. And I don't have that. So we had to start with it over 6. But then, if I differentiated that, not only would I bring down the power and subtract 1 from the power, I would also differentiate what's inside the brackets. I would differentiate 3x plus 1. And that would have given me a 3. But I don't have the 3 either. So I have to take that into account as well. Add my constant and then tidy it up. Okay, so we end up with 3x plus 1 all to the power of 6 all over 18, because that's 3 times 6, plus our constant. In general, we have this general form, and this is now given to you on your formula sheet, so this is not something that you need to remember. But the general rule is that the integral of ax plus b all to the power of n dx is equal to, you keep your ax plus b, add 1 to the power, put it over a outside of n plus 1. Okay, and in our example above, n plus 1 is 6, because 5 plus 1 is 6, and a is 3, because that's the coefficient of x. Okay, so pause the recording, have a go at this one, and then come back and check your answer. Alright, so if I integrate 5 minus 2x all to the power of 2, we keep our brackets as they are to start with, add 1 to your power, put it over power, and then I've got to multiply that by, well, what would the derivative inside the brackets be? It would have been a negative 2, isn't it? So I need to multiply that by negative 2. Add my constant, and I get 5 minus 2x all cubed all over negative 6 plus c. Doesn't matter where you put negative, you can put it in front, you can put it in front of the numerator, you can put it in front of the denominator. Hopefully by now we realise that they're all the same. Alright, I want you to have a go at exercise 3.5, and in this case I want you to do all of them. Okay, you need to be really, really confident at this stuff. Good luck, and I'll see you in class.